This is video number 1 for sections 11.4 and 11.5, Equations and Graphs of Ellipses. So as we wrap up the course, we are looking at some graphs of non-functions. We looked at the graph of a circle in the last lesson, and I have a couple of more examples to show you in this lesson. The first one is called an ellipse. An ellipse is basically an oval-like shape. You might think of it as a circle that's been squished or compressed in some way. To keep things simple, we will only look at two types of ellipses: a horizontal ellipse, which looks like this, or a vertical ellipse, which looks like this. We will also only be dealing with ellipses that are centered right at 0, 0. With circles, we were moving the graphs all over the place. We're going to keep these a little bit simpler. Well, let me go ahead and just tell you what the general equation of an ellipse is. Again, these are ellipses that are centered at 0, 0. And I've put it right here for you on the handout. This is the general equation of ellipse. In other words, this is like the y equals mx plus b for an ellipse. You can see there are some similarities to the circle equation because both the x is being squared and the y is being squared. But then there are some differences too. We've got these constants a and b. Our job right now is to figure out what the a and b do, what they represent, because if we can figure that out, it's pretty easy to work with these ellipses. So I made up an example problem. And let's do some investigating here and see if we can figure out what's going on. As you can see, the equation that I wrote down is an exact match to the general pattern. What about the a and the b? Well, in this example, the a would be 2, not 4, right? Not the number that's sitting there, because if you look carefully at the general pattern, the bottom here is the square of a squared. Well, if a squared is 4, that means a must be 2. In a similar way, if b squared is equal to 9, then the b must be a 3, because 3 squared is equal to 9. Another way you could say that is that a and b are the square roots of these bottom numbers. Square root of 4 is 2, square root of 9 is 3. Well, it turns out that the a and b have a connection to the x and y intercepts of the ellipse. And that's good, because even if you glance back up at my simple drawings here, if I was able to just figure out the 4 intercepts, the 2 x-intercepts and then the 2 y-intercepts, that looks like that would be plenty of information for me to draw a reasonable picture of the ellipse. Let's try to find those intercepts in our example problem here. We've been finding intercepts the same way the whole semester long. I'll start with the x-intercepts. I always find x-intercepts by setting the y value equal to 0. So I'll go ahead and do that. The y has been replaced with a 0. That makes this pretty easy to solve because, of course, 0 squared is just 0, and 0 divided by 9 is just 0, which means this whole part isn't really doing anything. I'm left with just x squared over 4 equals 1. I should clear the fractions by multiplying each side by 4. This is a quadratic equation. There's only one x showing, so I'm thinking the square root method looks pretty good. Square root, don't forget the plus or minus, and I end up here with x equals plus or minus 2. We have just discovered that this particular ellipse crosses the x-axis at positive 2 and as well as at negative 2, and so I can mark those points down. Now we'll find the y-intercepts. We know there's going to be 2. The process should be very similar. Let's fill in 0 for our x. This time it's the first part that zeroes out. This is just one big 0. Then I can clear the fractions by multiplying each side by 9. Once again, I've got a quadratic. The square root method will work nicely. Square root, plus or minus. and I'm ending up this time with y equals plus or minus 3. I can mark those points on as well. And then if I just connect the dots to form that kind of oval shape, I will have my ellipse. Of course, as usual, when we do these things, we look for patterns in the hopes that if we see a simple pattern, we won't have to do all this work again. I'm sure you have probably observed the pattern already. Why did the intercepts come out this way? Because of the values of a and b. The x-intercepts are plus or minus 2. Well, 2 was the a, the number that came from the x part of the equation. The y-intercepts are plus or minus 3. That's what b is, 3, the number that came from the y part of the equation. Let's summarize our findings here. Basically what we're saying is every time you have one of these things, the x-intercepts are just going to be plus or minus a, and the y-intercepts are going to be plus or minus b. Once you see the pattern, you don't have to do all the work again, and it makes these problems very, very fast. By the way, this example came out to be a vertical ellipse, right, because it's more up and down. You can easily tell that that's going to happen based on which of the two denominators is bigger. These numbers impact the a and b values. The reason this ended up vertical is I went 3 spaces up and down compared to only 2 left and right. If the number under the y squared is larger, you're going to have a vertical ellipse. If the number under the x squared is larger, you'll have a horizontal ellipse. Now that we have the basic understanding here, let's work a fresh example. So in this example problem, we're given an equation and we're being asked to draw a graph. This is an ellipse. It's just not in the right format, and I'm going to have trouble dealing with it until I put it in the right format. Remember, the general format has that 1 sitting over there on the right side. Unless you get the 1 and create these two fractions here, you can't see your a and your b. Well, it's pretty much the same way every time. I have a 10 on the right. I wish it was a 1, and so what I'll do is I'll simply divide by 10, and as long as I divide everybody by 10, that's a legal algebraic move. On the right side, let's simplify. The 10s divide out, and normally we would just write x squared, but I really want to see that fraction, so I'm going to leave it x squared over 1. The second one does not simplify, so I have y squared over 10. And on the right side now, I have a 1. This equation is now in that general ellipse format, which means I can very quickly identify the a and the b. A is the square root of the number sitting under the x. Well, the square root of 1 is 1. B is the square root of the number sitting under the y, which would be square root of 10. As long as you can identify the a and the b, you can make the graph very quickly. We know all these things are centered at 0, 0. We know the x-intercepts are at plus or minus a, so that would be plus or minus 1. We know the y-intercepts are at plus or minus b. That would be helpful here to go to the calculator. If you do, you will find that the square root of 10 is around 3.2. So I can't be perfect. I'll just roughly put my dots at plus or minus 3.2 and then connect the dots, and I've got my ellipse. This is also a vertical ellipse. Again, I could see that coming because the number below the y squared is bigger than the number below the x squared. One last quick example to mention here. Take a look at this equation. The question says, what would be the shape of this graph? And I think it's tempting to glance at it quickly and go, oh, well, of course, it's an ellipse. Look, it fits the pattern here. The a would be 2 because that's the square root of 4. The b would also be 2, which is the square root of 4. The other 4, the one under the y squared. We know these things are centered at 0, 0. The x-intercepts would be plus or minus 2. The y-intercepts would be plus or minus 2. But when you go to connect the dots, you realize, wait a minute, I'm not going to have a horizontal ellipse or a vertical ellipse here. I'm going to have a circle because I went out the same distance in all 4 directions. So that's the answer to the problem. The lesson here in this example is that if the denominators match, then you're not really looking at an ellipse, you're looking at a circle. In fact, to put this equation in the more normal circle format, all you would have to do is clear the fractions. You'd end up with x squared plus y squared equals 4. And when it's like this, I think it's pretty obvious, oh yeah, that's a circle centered at 0, 0 with a radius of 2, because this would be the r squared, as we learned in the last lesson. When you're doing your homework in my math lab, be sure to put the equation in the proper format first, identify your A and your B, and then you should be able to easily graph the ellipse. In the homework, those problems are typically multiple choice. You'll be picking from a selection of ellipses, and you just pick the one that fits the correct information.